Hi everybody, my name is Lee Petty and I'm Commercial Director of Albion Valves UK Limited. Today we are going to look at Albion's range of butterfly valves, but before we do that, please make sure you subscribe to our YouTube channel and also click the notification icon so that you can automatically get notified of any new content from us as soon as it's uploaded. So as I said previously, today we're going to talk about Albion's range of butterfly valves. We're going to look at covering several topics that I hope you'll find useful. These include what butterfly valves do, different types of butterfly valves in the Albion range, the recognised standards that butterfly valves are manufactured and tested to, the materials that butterfly valves are manufactured from and why these are chosen, the specific applications where butterfly valves can be used, and any accessories that butterfly valves can be paired with. We're then going to look at any specific product approvals that are applicable to our range of butterfly valves, and finally, pressure equipment directive classification, why this is important, not just for butterfly valves, but all valves in general. What does a butterfly valve do? A butterfly valve is used to control and regulate the flow of pipeline media, such as liquids or gases, by opening, closing or partially obstructing passageways to either start, stop or throttle the flow. Albion's day-to-day offering for butterfly valves can generally be separated into two specific types of valves. These are wafer pattern butterfly valves and lugged and tapped butterfly valves. As you can see from the examples I have just shown you, the design of the valve is almost identical apart from around the outside diameter where there's a considerable difference, and I will explain why this is during this video. First up, we're going to take a look at a wafer pattern butterfly valve. We have several of these within our product portfolio. They all have an almost identical design, but for different customer applications we would specify different types of valves. This would generally be determined by the specific on-site applications such as working pressure, working temperature and the media passing through it. So what do we mean by wafer pattern? A wafer pattern valve is a type of valve designed to be mounted between two pipeline flanges, secured by a series of bolts that pass through both of these flanges. This type of valve would connect to flanges either side of the valve by using a threaded bolt, whilst utilising nuts and washers for securement and leak prevention by compressing the protruding sealing face on the valve with the mating flange. Now let's take a look at a lugged and tapped butterfly valve so we can understand the differences. As we can see, the design of this valve is slightly different from that of a wafer pattern. You can see there are several lugs around the outside diameter, and these are threaded during the manufacturing process so that they can receive a mating bolt. This allows for a very different install method, which utilises two threaded bolts per lug, one from either side of the flange. There is a reason why wafer type design and lugged and tapped type design have different connection characteristics, and this is because it allows a lugged and tapped type design to be used for end-of-line service applications, as it can be securely fastened to the flange by way of bolt from one side only. The most important thing to consider when using a butterfly valve for end-of-line service is that the maximum working pressure should be reduced by 50%. At any other time, it is good to operate at its design rated pressure. It's always important to follow a logical method when bolting valves into pipework. You can find a technical guidance document on this subject on Albion's website, www.albionvalvesuk.com. Now let's talk about specific standards that Albion's range of butterfly valves are manufactured to. Albion's range of butterfly valves are manufactured to BS EN 593. This standard links directly to several other relevant standards. All of these standards, when used in harmony, define specifics such as general design, working pressures, temperature limitations, material of manufacture, geometric requirements and their tolerances, and any specific testing that is relevant to butterfly valves. We have now had a look at the general design of butterfly valves, both wafer pattern and lugged and tapped, and the primary reason why you may choose to use one over another. Now let's have a look at the different types of materials that they are made from. First of all, let's look at the main components and materials of butterfly valves, what they do and how they will work in unison. As you can see here visually, we have a valve body, a valve disc, a valve lever or handle, and finally a valve seat. The valve body of a butterfly valve is the outer shell. This houses the internal components, connects the valve to the pipeline and handles the pressure of the fluid. It provides a secure enclosure and is a main structural part of the butterfly valve. Albion's range of butterfly valves are made from ductile iron bodies. We choose this type of material as it has good strength and flexibility characteristics. The valve disc of a butterfly valve rotates through 90 degrees to control the flow of fluid, gas or slurries through a pipe. When the disc is perpendicular to the flow or fully closed, it blocks it completely. When parallel or fully open, it allows the maximum flow. By positioning the disc at an angle between 0 and 90 degrees, it can be used to throttle or regulate the flow. Any information that is needed regarding flow rates for butterfly valves at any given position can be found either on our website or via Albion's internal technical team. Albion has butterfly valve discs that are manufactured from several materials. These include materials such as stainless steel and nickel-plated ductile iron. This allows valves to be chosen for specific site and media applications. A valve lever, in terms of the operation of a butterfly valve, is reasonably simple. It's a 90-degree rotator around an axis that takes place by applying a torque to the lever. By opening and closing the valve in this way, it allows the media to flow fully, have the flow regulated, or make the flow stop. One of the most interesting things regarding the design of butterfly valves, and as I briefly mentioned earlier, is that they can regulate the flow by opening the disc at a given angle between 0 degrees and 90 degrees. A valve seat in a butterfly valve provides a sealing surface between the disc and the valve body, ensuring a tight shut-off when the valve is closed. It prevents leakage of the fluid by creating a seal against the edge of the disc. The seat is a critical component as its material, design and condition directly determine the valve's sealing performance, durability and suitability for different applications. Albion's range of butterfly valves come with either EPDM or MBR seats. It is important, however, that due consideration is always given to on-site medias and service conditions when determining which type of butterfly valve to select. There are also some other components within a butterfly valve that you can't see, such as upper and lower shafts, which connect the lever and the top of the valve in turn drive the disc when a torque is applied. There are a couple of seals in the stem which prevent any media leaking to atmosphere. Ordinarily, these parts do not come into contact with any media. There is a cotter pin which acts as a fastener device and a circlip which prevents any movement of the components of the butterfly valve. All Albion's range of butterfly valves are tested to the same standard. This is BS-EN 12266 and it incorporates several tests. These are a shell test and a seat test. A shell test is to verify the pressure containing capability against internal pressure. The valves in this test scenario must be able to withstand 1.5 times the maximum working pressure of the valve with no leakage present. A seat's tightness test. The purpose of this test is to confirm the capability of the seat to conform to a specified leakage rate. For butterfly valves, that is 0 allowable leakage across the seat. The test pressure for this test is 1.1 times the maximum working pressure. Albion's range of butterfly valves come with several different types of accessories that allow for different types of operation. These include gearboxes, pneumatic actuators, and finally, electric actuators. Firstly, let's look at gearboxes. These can be mounted onto the top of butterfly valves where they can sit directly onto several mounting holes. The mounting holes' geometrical tolerances are taken directly from the standard ISO 5211. These gearboxes are suitable to all sizes across the range, but are particularly well suited to the larger size valves where a higher torque is required to operate the butterfly valves. Albion always suggests that for butterfly valves at 8 inch and above, a gearbox is used as this will assist with the operation. Now let's look at pneumatic actuators. Albion's range of butterfly valves can also be used with air-operated pneumatic actuators. Further to this, the air-operated actuators can be used in conjunction with a Nemua type spool valve, which can be wired directly into a building management system to provide an input signal, and with one of our switch boxes, which can then provide an output signal to the same building management system. If neither an input nor an output signal is required, a pneumatic actuator can be manually operated. These types of actuators work just like the pneumatic actuators when used in conjunction with the Nemua and the switchbox accessories, and allowed feedback signals to be both sent and received. These electric actuators can also link into a building management system. One of the great things about Albion's range of both pneumatic and electric actuators is that they can operate in either a fully open position, a fully closed position, or even a proportionally controlled configuration, which is an ideal solution to regulate and control the flow within a pipeline system. For any actuator requirements, Albion are happy to ensure the correct actuator is fitted to the correct valves for your chosen on-site application. Just give our sales team a call and they will be sure to give the best advice. Some of the valves within Albion's range of butterfly valves come with RAS approval and can therefore be used on drinking water systems. All polymers that come into contact with water on these valves have a BS 6920 approval, so can also be used on applications that are governed by the Drinking Water Inspectorate. If these types of approvals are not required, and you require a valve for a heating or cooling system, or even a gas application, you can rely on Albion to be your trusted partner. Now we're going to briefly touch on the Pressure Equipment Directive. As with all valves within our product portfolio, Albion's range of butterfly valves conform to the requirements of the Pressure Equipment Directive. Sometimes this is referred to as PED. Any certification that may be needed for Albion's range of butterfly valves can be found either on our website at www.albionvalvesuk.com or by contacting our in-house quality team directly on 01226 729900. That's all for today, but remember to ask for Albion for your valves, actuators and fitting requirements, available through your local independent distributor and suitable for a wide range of building services and industrial applications. Find product information including data sheets, IOMs, BIM components, approvals and general guidance at www.albionvalvesuk.com.